Hello all. Welcome to physics test series as part of KANA Academy. I'm Karthik. In the video, we will see how to solve the questions one by one. Just feel free to pause the video and spend some time in reading the questions. Yes. So we'll go to the first question. So here it has been given that there is a particle on a table on a string, radius decreases by a factor 2. So that means like R becomes R by 2 by pulling. So this question is based on the concept that there is no external torque. So it is based on the concept that there are no external torque about center. This means angular momentum L is conserved. So this is the main key idea that you should remember. So if it is angular momentum is constant, this means V is inversely proportional to R. If R becomes R by 2, then V becomes simply double. Right, so it should be 1 by 2, so it becomes 1 by 1 by 2. So then kinetic energy becomes, it's directly proportional to V square, velocity square. So if velocity doubles, kinetic energy, it increased by a factor of 4. Right? So this is the answer for this first question. Next one. Yeah, there is a 3-point mass system. So we take this diagram. So this component can be written as, so let's say this part is 30 degree. And this is A. So then here it will be A sine theta. That is nothing but sine 30. Okay. Yeah. So let's see how to go about this question. So there are 3 masses, like at the points A, B, and O. So they are the vertices of equilateral triangle. Triangle side on the A solitaire. So then we need to find the moment of inertia I about the axis COD. So this is the axis. We need to find the moment of inertia for this problem. So for this, formula is that m r square. It's the perpendicular distance from the axis. So there is one mass is on axis, right? Yeah. So the r value up to 0 around. So that will get cancelled. For another one, r is equal to a by 2. So if you draw like this for equilateral triangle, so either distance on the again this will be a by 2, this will be a by 2. So another r is a for another mass, it will be a. So if we just substitute in the equation, it will be summation of mass into 0 square plus mass into A by 2 square plus MA square. If simplify panna, you will get it as 5 by 4 times MA square. So you just need to remember that equilateral triangle, you just need to find the R values for each masses, then you just simply substitute in this question. Yeah, next question. Yes. Okay, so 1/4 sector is cut from a uniform circular disc of radius R, so and so. Okay, so there is a given is that there is a 1/4 sector. It is cut from uniform disk radius R, and this sector has a mass of M, and we need to find the again I about axis. So we need to find the definition I about the axis through the center of original disk perpendicular to the plane. So the concept in I scales with mass for same shape about same axis. Okay, so for full disk, it would be 4 times M. So I full about center will becomes, it will be half 4M R square. So it will be 2M R square. So quarter sector on it's 1/4 of the full disk. So we just need to make this value the actual moment of inertia for this part, this quarter can, so this is like, let's say this I, so I star, which is our actual value is, simply we just need to divide it by, yeah, so it will be 1 by 4 times in this 2M R square. So it will be 1 by 2 M R square. So it's option E. Next one. So there is a rotating platform. And there's a viscous fluid that has been dropped at the center. It spreads out, then falls off. What happens to the omega during this time? So here, concept is that there is no external torque. So this means angular displacement is not angular. Sorry, the L is and this is conserved. Okay. So this is conserved as the fluid spreads outwards. I value increases. This means omega decreases. Okay, but this is not the only thing. When fluid falls off, like the system loses that mass distribution. Like when the fluid fall off on a mother, I actually decreases. So when I decreases, omega increases. So first it will be angular velocity will be decreasing, and then it increases again. It's because I value is opposite of that. First I value increases and then it decreases. Okay, next question. Yeah, so for the same total mass, which has largest L about, I about the axis through CG perpendicular to a plane. So they have given us a disk of radius, then ring radius, a square lamina side of 2A, and 4 rods of side 2A. Okay. So here the main concept is that so I is largest. So moment of inertia for I is largest when mass is distributed farthest from axis. Right. So if you know the relationship between I and the R, the distance from the axis, you know this. When the mass distributed furthest from axis, it will be I will be largest. Okay. So இதுல என்னென்ன கொடுத்திருக்காங்க, there is ring is greater than disk. So ring is greater than disk, then rods on the perimeter distribute more mass far out than lamina. So overall it will be C actually. C is the answer. But இது வந்துட்டு it's just by applying the logic of where does the mass, how is the mass is distributed, right? So if you want to go to mathematically, it will be I discuss m a square by 2, I ringus m a square, I square lamina is m into L square plus v square by 12. It's almost like, so it will be a square plus a square because it's a square, and then it will be 2 times m a square by 12. Okay. And then for I rods, it will be m by 4 times 4a square by 12 plus m by 4 into 2a by 2 square. And there are all of this is multiplied by 4 times. So this will be 4 m a square by 3. So we have to find the largest moment of inertia. So that's for C square lemma. Yeah. Okay. Next question. Yeah. So there are 2 uniform thin identical rods. Each mass is m and length L is joined as a cross. Find the I about the axis. So it's again the moment of inertia problem about the axis through the joint perpendicular to a plane. So for formula for this is that I is m L square by 12. Okay. So this is for rods. So since the axis passes through each rod's center, total I is 2 times of this, ml square by 12. So if we solve this, it will be ml square by 6. It will be option B. Okay. Next one. So there is a circular ring and a disk of same mass m and radius r. The ratio of I about center perpendicular to the plane. So for you need to compare ring and then disk. For I, for this it will be m square. For disk it is half m square. So ratio is the ratio of this m r square. So that is like by m r square. So ring by disk. So this will be 2:1. Please remember this formula, like in the inertia, ring account, disk account, it's really important. Like you know the moment of inertia for ring and disk. Then 8. So if there is a net external force on system as 0, which may vary. So that is the thing. So like, for example, if F external is 0, that means P is constant, right? Because then only dP by dt will become 0. If if P is constant, the velocity of the center of the mass will also be constant, because P is nothing but m into v. So m is always a constant. I mean, m is a constant for the system. So m is not going to change. If P is constant, it has to, like, even the v has to be constant. So momentum and the velocity, these are supposed to be constant. So we can eliminate these two options. The next is the position of the center of the mass. But so like actually in this case also, like if the external force acting on the system is 0, like the center of the mass position can change actually. It can change with the time. Only if this velocity of the center of mass is non-zero. Constant, I mean, it is constant, but it is non-zero. In that case, the center of mass position can change. But it doesn't mean that like velocity constant it doesn't mean that it's 0, right? So based on this, answer for the 8th one is option C. Next one. There is a circular disc of radius r with a circular hole of diameter r. The whole radius is like diameter is like r, so then the radius for this whole this part is r by 2, and find the shift x of center of mass left of original center. So we need to use the concept here, use removed mass. Okay. So mass of the remaining disk is pi r square p minus. Yeah. Will be into this will be so the center of mass of the remaining disk with respect to the center of the original disk using like m1 x1 equals to m2 x2. This part will become pi 3 t square by 4 2 times x. This will be pi t square by 4 t v 4 into r by 2. That's r by 2. So இதை solve பண்ணோம்னா x க்கு equal the remaining compound will be 3 here, so it will come down, and then there is a 2 here, so it will be denominator part, it will be 6, and the numerator it will be only r is left. So it is r by 6. Yeah. So 10th question. So there is a wheel rotating about 720 rpm with the constant opposing torque. Torque brings it to rest in 8 seconds. And I is given as like 24 by pi kg per meter square, kg dot meter square. So find the torque. Okay, so first 720 rpm means 12 revolution per second. So that means, so omega dot is, when omega initially is 2 pi into 12, so that is 24 pi radians per second. And angular acceleration is 0 minus omega. Okay, so this will be minus 24 pi by t is 8 seconds. It will be 8. So this will be minus 3 pi radians per second square. Okay, so the torque is I times magnitude of this angular acceleration. So I is given as 24 by pi here, and then this is 3 pi. So it will be 24 into 3, that will be 72. Next question. So it's an assertion reason based question. So assertion la the tornado's wind speed may vary. Speed, I mean, like tornado's wind speed is very high. So reason is if no external torque acts, the angular velocity remains conserved. So correct here is that tornado air column contracts. So actually what happens when there is tornado air column kind of contracts. So when air column contracts, so I decreases. Right, so think of this R value. So R is decreasing, so I also kind of decreases. This, the omega increases since L is equal to nothing but omega, which is a constant. So as this L is constant, if I is decreasing, omega has to increase so that this L remains as a constant. But reason says that omega will be like this angular velocity remains conserved. So that is not the case. So I mean assertion is right, but the reason explaining that is not right. So it will be option C. Okay, so next 12th one, there is a barb of mass M, it is attached to an inextensible string of length L. So and so, with from vertical support, the bob rotates in horizontal circle with an angular speed of omega. About the point of suspension, they're asking about angular momentum. Like there are some statements we need to understand what would be the case. So here, the concept of angular momentum is R times A, right? R times the radius times the momentum, linear momentum. So here, magnitude stays constant. Magnitude is constant, but direction changes. Okay. So as Bob goes around, so like, so let's say this is and your Bob. So it's usually moves around the center, right? So it goes around like this. So in that case, the magnitude of the angular momentum is the same, but it's the but the direction is keep on changing. So adhigran, so it's option C. Yeah, next question. So there are two blocks, A and B on a smooth surface with equal speeds 2 meter per second in opposite direction from this one. And find the CM coordinates, the center of mass coordinate at t is equal to 3 seconds. Okay, so since m is equal for both, like m1 and m2 is equal, and v is only in the negative. V1 is like negative times V2. So this implies the center of mass velocity is 0. Means like center of mass position is fixed. Okay. From given initial positions in the figure, so x is equal to, it's nothing but so it will remain as the same point. Right. Yeah. So it will remain as the same point. Yeah. So if you want to find the actual x in centimeters, it will be m1 x1 plus m2 x2 by m1 plus m2. So if you substitute these values, both of them are like here 4, but x1 is an origin, so this will become 0. So this will be 4 times 4.5, 4 into 4.5 by 4 plus 4, 8. So this will be 2.25. So x is 2.25, but the y point is, it will be 0 only. So it will be option D. Yeah. Okay. Next question. So just in the we just keep it in mind this part, like center of mass position is fixed. That's why like VCM is equal to 0. But XCM, we find it with the conventional formula for the center of mass. So other which we can just find the answer. Okay. Next question. Yeah. So there is a solid cylinder. It rolls down an incline without slipping. Find the rotational kinetic energy with respect to the total kinetic energy. So we know that K total is nothing but half mv square plus half square. It's nothing but V by R. So it's a cylinder, right? So for the cylinder, I is 1 by 2 m r square. So if you substitute, if you find it for kinetic energy for rotational, and the rotational energy is 1 by 2 into 1 by 2 m r square into v square by r square. Okay. This will become like 1 by 4 r square will get cancelled. It will be 1 by 4 mv square. So fraction, if you want to find the fraction of it, will be, let's say, k rotational to by k total. It will be 1 by 4 divided by 1 by 4 plus 1 by 2. So basically we cancel out all this mv square terms. So we'll be left with this fractions. So if you solve for this, you will get it as 1 by 4 by 3 by 4. So it is nothing but 1 by 3. So answer is B. Okay, it's a assertion reason based question. Here assertion says that ladder is more likely to slip when you are high up. So ladder slips when you are high up. Okay, and reason says that at a high point, see, so when a person is high up on a ladder, there is a large torque due to his weight about the point of contact. So that's whereas when he starts climbing up, like the torque is small. So the ladder is more apt to slip when the one is high up to it. See, for example, so let's say there is a wall. Let's say this is the ladder. Yeah. So the torque பார்த்தோம்னா, like it's very high. So இந்த ரெண்டு பாயிண்ட்ல எங்க டார்க் high and low இருக்கும்னா we should know. So at a high point, like the torque is large. So at this point, the torque is large. So while starting to climb up, it's very small. So that's why like it slips. So this is the actual reason. So the reason is right actually. So that correctly explains the assertion as well. This we know at universally, like ladder is more apt to like like நமக்கு நிறைய chances இருக்கு நம்ம ladderல மேலே ஏறும்போது like ஏறும்போதே ஒன்றும் slip ஆகாது. It's mostly when you climb closer to the top, that's when you can easily get slipped. It's big. The reason behind for this is a torque ஓட magnitude வச்சு தான் இது decide ஆகுது. Okay, so the answer for this will be A. Okay, next question. Yeah, so there is an incline 30° with a solid sphere rolling without slipping. Find the linear acceleration. So linear acceleration is AG sine theta. Yeah. 1 by gamma square. Yes. So based on this, a sphere will be I is 2 by 5 gamma square. So this means A is equal to G sin theta by 125. So we substitute this value here. So just will be just left with the 2 by 5. And this will be G sin theta into 5 by 7. So sin theta here, theta is 30 degree. So you can substitute that as well here. So A becomes 5 by 7 into 2. So it is 14 times G. So it is D. Okay. Next question. Yeah. So there is a two coaxial wheels, radius on the R and 2R. So they are attached. The strings, they don't slip. The distance moved X and Y in same time. So either a concept பார்த்தா major concept is based on there is a same angular displacement. The theta is same for both because it's rigidly connected, right? So X is equal to R theta, Y is equal to 2R theta. Yeah. Okay. So then this means Y is equal to is just solve for, I mean, like நம்மகிட்ட இப்ப ரெண்டு equation இருக்கு for X and Y. If you want to find the relationship, I mean, like linear set of equations இருக்கு. So இதை solve பண்ணோம்னா you will get Y is equal to 2X. Okay. Then next question. It's a moment of inertia for a uniform disk about diameter. Like they are given that as like a I. And find the moment of inertia about axis perpendicular to the disk through a point on a rim. So for disk, moment of inertia in about diameter is m(r) square by 4. This implies I is something like m(r) square equals to 4i, right? Yeah. And moment of inertia, now we need to do about center perpendicular. So it will be IC will be half m(r) square. So this will be the m(r) square is this is 4i, right? So this will be 4 times I. So it will be 2i. So if you use this parallel axis to the rim point அப்படி பார்த்தோம்னா, so I about rim வந்து it will be I center plus m(r) square. So center we found it as 2i plus this is 4i. Yeah. So this will be total is 6i. Yeah. Next question. Yeah, it's a rotational kinetic energy is like 50% of translational kinetic energy. Then the body is what and get to go. So we need to find the shape. I mean, like what type of body, I mean, what is the type of the body? So for rolling, பார்த்தோம்னா, first rolling, K rotational by K translational is I omega square by mv square. So this will be I by m r square. So they have already given this. This ratio is 0.5. Okay, so I by this is equal to 0.5. So this implies I is equal to 1 by 2 times m r square. So if you get this equation in the moment of inertia, it is like half m r square, and it is for like a cylinder. It's like for a solid cylinder. So basically, we just substitute the rotational energy, kinetic energy formula வச்சு போட்டுட்டு ரெண்டுத்துக்கும் rotational and translational energy, I mean translational energy போட்டுட்டு, and then they were given already the ratio and the value substitute பண்ணிட்டோம். Then we just found out a relationship between the I and then a moment of inertia, and then like with respect to mr square, I mean mr square relationship, if we find a relationship for all these three factors, we can figure out what type of body it is based on this formula. So it is option B. Yeah. So the next question is 20th. So there are two identical particles, one has acceleration A and other at rest. So that means like zero acceleration. Find the acceleration of center of mass. So A of center of mass is that A1 plus A2 by 2. So it is A plus 0 by 2. So it will be A by 2. Okay, next question. Okay, they have given the equation for a displacement so and so, and we need to find the angular displacement omega at t is equal to, we need to find omega at t is equal to 2 seconds. This is nothing but d theta by dt. So if we differentiate this equation, it will be 6t square. So omega of 2 seconds, it will be 6 into 4, it will be 24 radians per second. Yeah, so it's straightforward. Are the 22nd? Okay, this is a little bit about the statement based. So they have given that there is a turntable plus pan of ice is rotated. Then driving withdrawn, like no friction with the table. So as ice melts, like what happens? So there is no external torque. Okay, if there is no external torque, angular momentum is conserved. So the melted water, how it spreads outward. So water spreads outward. So that means I increases because R also increases, or I increases. So this means what? This decreases. It's like a few questions முன்னாடி பார்த்த அதே concept தான். So it will be answer A. The angular velocity of the system, it decreases. So this it doesn't increase. So yeah. So another one is like the moment of inertia of the system decreases in Traganga. So, but actually the moment of inertia on the it increases. Okay. So next question. Yeah. So there is a circular disc to be made by using iron and aluminum. It requires moment of inertia about its geometrical axis. It is possible with what? So disc is made from two different materials, iron and aluminum, to maximize inertia about the central axis. See, I is maximum when heavier material is farther from the axis. So I is max when heavy material is farther, right? Because it depends on both the mass as well as the radius. I mean, not the radius, I mean the distance from the axis. So R. So, but if there is a heavy material, if it's further, farther இருந்துச்சுன்னா, it will be at the maximum value. Like I would be at maximum value. Since iron is denser, so like we need to put the iron outside, aluminum on the inside. Okay, so it will be option B. Aluminum as interior and iron surrounding it. Okay, so there is a wheel with a radius of so and so, and forces, like there is a 4 Newton at A, so there is 4 Newton force at A, and then 8 Newton, 6 Newton, and 9 Newton at various points at given angles. We need to find the net torque. Okay. Yes. So in order to find the torque, it will be 9 into 8 sin 30. So yeah, minus 4 into 0.2, because it's radius of 20 centimeter. Yeah, 0.2, and it's in clockwise. Yeah. Okay. So it will be 1.8 Newton meter in clockwise. Yeah. Next question. So there is a rolling wave of the center speed of VO and the particle on rim at the same level as the center. So what is the speed? So at side point, velocity is equal to, so vector sum of translational view forward and rotational view, it's vertical. So magnitude padi paatha, it will be view plus view square around, so it will be root 2 times view. Yeah. Next one. Okay. So there is a uniform circular motion, and angular momentum is L. If the frequency doubles, the new angular momentum is what? You get again. So angular momentum is what? So it's I times omega. So here omega is nothing but 2 pi frequency of F. So L is directly proportional to frequency. So if F is doubled, L also doubled. So it's 2L. Okay. There is a meter stick, half wood. It's like half wood and then half steel. Case A, pivot is at wood end. So இதில் வந்து first wood endல இருக்கு. அடுத்து the pivot end வந்து பார்த்தீங்கன்னா second caseல it's steel is it at the steel end. the same force at the other end, compare the angular acceleration சொல்லிட்டாங்க. So this is same. So F into L into so since this is I is larger, it is larger when heavier part is farther. Right, couple of questions முன்னாடி பார்த்தோம்ல copper and sorry aluminum and iron questions la. So it's the same concept. So relatively steel is right. So yeah. So the case is that in case A, pivot is at wood end. So then steel is far. That means so in the case, the first case la I is larger, right? If I is larger, angular acceleration is smaller. In this case, I is smaller, so angular acceleration is larger, right? So the answer is case B. So they're asking about that. So in terms of angular acceleration, it is greater in this case than in V. It's definitely not equal. Yeah. Okay. So the position of particle is given by r vector, and then momentum is given. What is the angular momentum is perpendicular to what? Get it down. So it's a vector based question. So if you have r and then p vector, so then L is nothing but product of p. So it will be I j k, and then it will be 1 2 minus 1. It will be 3 4 minus 2. So if you solve this, you'll get minus j minus q. So this means I vector and the I, there is no I component, so I component of the 0. So that means what it says is that it's a L is perpendicular to x-axis. That's why like I is it's 0 I. It's 0 I minus j minus 2k. So it is x-axis. Yeah. Okay, next question. There is a body falling and vertically downward under gravity. So it breaks into two unequal masses. How does the center of mass shift horizontally? So concept here is that only external forces, it's gravity and it acts vertically. So there are no external horizontal force. The center of mass, hence it cannot accelerate horizontally. So it does not shift horizontally. So it is not relevant. There is no such thing as heavier piece and the lighter piece when it comes to the center of mass with respect to this question. Yeah. Okay. Next question. Yeah. So concept, it's almost as the previous question. So the angular momentum is mv times I, or it's like it's linear momentum into perpendicular distance, right? Yeah. So Here the question is, a body is falling vertically downward under the gravity, breaks into two unequal parts, unequal mass, the center of mass of the parts taken together shifts horizontally towards. So here, like the center of mass taken together, like which side it shifts towards கேட்டிருக்காங்க. So it will be towards the lighter piece. It's because of this perpendicular distance component. Okay. Next one, there is a solid sphere. So it's a solid sphere, there is a disc and cylinder. They are of same mass and material. They have been rolled down, inclined from rest. Which reaches first? Like among them, which is going to reach the first அப்படின்னு சொல்லிட்டு. So concept here is A is equal to G sin theta by 1 plus gamma square. Okay. So that means if there is a smaller I by gamma square, it will be larger A. So these things is going to remain the same. It's only this part it's going to determine. So I by gamma square க்கு எது smaller இருக்கோ, then we will have the larger A value. So if you compare it for the compounds like solid disk, solid sphere, and then solid cylinder, it is solid sphere that leads. So it will be solid sphere that reaches the bottom first. Okay. So 32. So there are two rings with the planes perpendicular. Find I about axis through center perpendicular to the plane of one ring. So ring 1 எடுத்துப்போம். So ring 1 க்கு it will be I1 should be m r square, and ring 2. So as axis lying in its plane, so it will be of inertia about diameter is 1 by 2 m r square. So the total I is m r square plus 1 by 2 m r square. So this will be 3 by 2 m r square. Okay. Next question. Okay. This is a concept based question. So there is a solid cylinder and solid sphere, both with the same mass and radius. They are released from a rough inclined plane. They both roll without slipping. So there is no slipping. So for rolling பார்த்துக்கிட்டோம் அப்படின்னா the same like இதுக்கு முன்னாடி பார்த்த equation. So A is G sin theta by 1 plus I by m r square. Friction required, it depends only on this I component. So larger I means if there is a larger I, we need more friction. Larger I means like more friction. Cylinder has like it's the cylinder I, it has the larger I than the sphere because the contact cylinder it has more, so the friction will be more for in terms of cylinder than the sphere. So hence the answer is C. Force of friction is greater in case of cylinder than in sphere. Yeah. So next 34th, there is a homogeneous disk of mass 2 kg and the radius is 15 centimeter. It's rotating about its axis with an angular velocity of so and so. What is the linear momentum of the disk? So it is mv centimeter. I mean the velocity of the center of mass. Okay. So here it's a little tricky. So its mass is 2 kg, but this component is 0. The velocity of the center of mass is 0 because it's a homogeneous disk. So it will be none of this. Okay, next question. So there is a equation for angular velocity. You need to find the angle rotated about before stopping. So it stops when, sorry, stops when is 0. That means time to stop is alpha times beta. So when if you just apply this equation, because they were given angular velocity as alpha times beta t. So if you substitute this as 0, we can find a t as alpha by beta. So if you come back to theta, it will be yeah. So how to find the angle? It will be 0 to infinity alpha times beta beta t and dt. It will be so if you solve for this, we'll get it as alpha square by beta minus alpha square by 2 beta will be alpha square by 2 beta. Yeah. Next question. So there is a motor engine of 100 RPM. It stops in 15 seconds without with constant deceleration. You need to find the revolutions before it stops. So this is 100 into 2 pi by 60 radians per second. So for uniform deceleration, average omega is by 2. So if you substitute this implies theta is omega average. So this will be omega times 2 into AT is 15 seconds. So yeah, and revolutions n is theta by 2 pi. So we have theta is this value, and if you substitute, and omega is here. So if omega value theta la போட்டு theta in the equation substitute பண்ணோம்னா we will get it as n as 12.5. So there is equation 1. Substitute equation 1 in equation 2, then substitute that in this final equation 3. Yeah. Okay. So 37. There is a T joint of two identical rods. Find the moment of inertia about axis through A perpendicular to plane. So about A perpendicular to the plane. So how to go about this? IA is m L square by 3 plus ml square by 12 plus ml square. So simplify பண்ணோம்னா it will be 17 by 12 times. Sorry. Yeah, it will be 17 by 12 times ml square. So it will be none of this. Okay. Next question. There is a hollow sphere of diameter so and so, and so radius is 0.1 meters, then mass is 10 kg, rolling speed is given, so find the kinetic energy. So rolling kinetic energy pata, it will be k is half mv square into 1 plus k square by r square. Okay, so for a hollow sphere, this k value is k square is, this is 2 by 3 r square. So the factor is, this factor is 1 plus 2 by 3. So the entire factor becomes, it's 5 by 3. So for kinetic energy will be 1 by 2 times mass is 2 kg and 0.5 is velocity square into factor. So usual half mv square into factor. So the factor is computed from here for a hollow sphere. So if we solve this, we'll get it as 0.42 joules. Yeah. Okay. Next question. There is a light cord wrapped around a rim of disk radius r. Downward pull is F and find the angular acceleration. So here torque is Fr, and for the disk it is I is 1 by 2 gamma square. So alpha is 1 by I. So it will be Fr by 1 by 2 gamma square. So it will be 2 times F by mr. So it's option C. Next is, there is a mass of 5 grams, speed is given, and it moves along the horizontal line y is equal to 2 root 5 centimeter. Find the angular momentum about the origin. So இதுக்கு direct formula தான் apply பண்ணோம். So it will be mv b. This b is perpendicular distance from origin to the line of motion, which is nothing but y. So it's this one. So it will be 5 times velocity is 3 root 2 into this b is 2 root 5. 5 3 15, 15 into 2 30, and then 5 into 2 is 10. Yeah. Next question. So a ball is kept in a ball, like it collides with the walls inside the box, and the box is on a smoother surface, which center of mass velocity remains constant. So there is no external force. Okay. So on box plus ball, the entire system, there are no external force. This means velocity of the center of mass is constant. So it will be this one. We don't, this concept is repeated again in this series. Okay. Next one. So two solid cylinders, P and Q of same mass are it's a roll down incline, and P has mass near surface larger I, and Q near axis, so it's a smaller I. Choose the correct statement. See, the smaller I na, it's a larger acceleration. So Q reaches first. So this is also like a repetition. Okay. So Q reaches first. So we saw it because of the angular momentum being constant. That's why it's smaller I is means like it has to be larger. This is just a recap of what we discussed before. So Q reaches first now. It means larger W as well. So only statement correct is that it's that Q reaches with larger angular speed. So it is option D. Yeah, it's this one. So cylinder Q reaches the ground with larger angular speed because the rest of the statements doesn't make sense. Okay. So next question. So the object rolls a curved surface with initial speed v, and then maximum height is given maximum height. Identify the object. So like let's go from the energy perspective. So it will be half mv square into 1 plus this factor k square by r square equals to mg h. So if we solve it for h, it will be v square by 2g into 1 plus k square by r square. So in h it's 3v square by 4g. So if you compare, if you substitute that here, so in there is nothing but 3v square by 4g. So we can cancel this. This becomes 2. So simply k square by r square becomes will be 1 by 2. Yeah. So if k square by r square in this shape 1 by 2 it will be for the disk. So these are some things. இதுக்கு வேற ஆப்ஷன் இல்ல, you should keep it in mind at least for this common figures. இந்த மாதிரி அடிக்கடி வர figuresக்குலாம் you should remember these values, like what like for ring especially ring and disk is very common to I mean like ring and disk தான் இருக்கிறதுல ரொம்ப காமனா இருக்கும். அதுக்கப்புறம் வர்றது பாத்தீங்கன்னா mostly இந்த spheres, hollow and the solid spheres வர்றது next favorite. Okay, so 44, a mass slides down incline and reaches bottom speed v. If instead it is a ring rolling down, what is the speed? So sliding v is root 2 gh. Okay, and rolling this was sliding. So rolling now it will be root 2 gh by this 1 plus k square by r square. We have to incorporate that factor into the account. So அப்படி பண்ணும்போது எப்படி ஆகும்னா like rolling v dash could be root 2 gh by 2 naya. So it will be root gh. So this will be v dash is nothing but v by root 2. Yeah, so இது எப்படி வந்துச்சுன்னா it's root 2 gh by 1 plus k square by r square. Okay, so we இதுக்கு வந்து substitute பண்ணா by 2 போட்டுட்டோம். So that's why it becomes like this. Yeah. So that answer is C. Next question. The last one. So yeah, so it's based on body goes down the same incline, but it is in two different ways. One is slipping, another one is there is no rolling. It's a smooth block. Second case is like it's a rolling without slipping. That's a solid sphere. We need the ratio of the accelerations. So okay, let's see how to solve this. So first is case 1, that's slipping only. So it's purely translational. So acceleration slip is nothing but g sin theta there is no rotation. So all the pull like mg sine theta goes into speeding up the block linearly. So then there is case 2. It is rolling without slipping at all. So hence a part of like this mg sine theta is used to increase the linear speed, increase the linear speed. So this mg sine theta is used to increase the linear speed and also increase the rotational speed. Okay, and so acceleration rho is g sine theta by 1 plus I by m square, where I is 2 by 5 m square. So sorry. So if you rearrange this equation, I by m square is nothing but 2 by 5. And in the equation, it will be g sine theta divided by 1 plus 2 by 5. When you simplify it will become 5 by 7 times g sine theta. Okay. So we got this one as well. So now we just need to find the ratio of A roll by A slip. So this will be 5 by 7 g sine theta by g sine theta. Okay. Simply 5 by 7. It's like 5:7. So that's the final answer. 5:7. Okay. That's it from my side. Thank you for watching this video.